Hi, my name's Alfredo Alvarez, and this is my demo for PaletaUi, which is a project I've been working on the last 3 months as part of Depaul. So what is PaletaUi? PaletaUi is a declarative UI system for the game engine Azure, which is the game engine that we have built here at Depaul. Alright, so basically what you're seeing on screen it's a demo that I made that shows the different things that you can do with PaletaUi. So let's get started, and I'm going to go walk through the demo and explain what each scene is, and then we're going to look at the code and see how they got done. So basically, PaletaUi works in two ways. You can manage it programmatically, or you can manage declaratively using XML. So for programmatically using it, what you do is you basically create a view, which is your top object. A view basically represents the entire drawing space. So you have one view that goes from here to here. And a view will draw on top of a scene. And the scene is where my 3D image, which is where that ship's coming from, it's being drawn. So what we can see here is we have a view that's invisible. And then on top of that we have a frame. And the frame is going to give us our drawing order. So basically we use frames to control the C order. And what we have is a coordinate system that works relative from the bottom left, and you can go adding elements in, which are called widgets, and building your scene, building your frame. So this is one view with one frame, and inside the frame we have a panel, which is a container for widgets, and then we have button widgets and label widgets to make the UI presentation for the entrance of this game, Space Race. So Space Race is not a real game, it's just something I did for the demo, just so it's clarifying. So we're going to hit start. Like I said, this was programmatically made, and I'm going to take you really quickly so you can see what the code looks like for programmatically making that view. So if we go here, starting screen scene, this is basically what my header looks like. It's pretty simple. All my scenes have all these methods. The scenes are not part of the system, but they're part of the game engine. Okay, so basically a scene gets initialized, and in initialization it has to like create what we're gonna see. So all over here what we have, all this is just our model, and it's how Azure loads a model. Basically it's setting the lights, setting the positions, and that's basically Azure stuff. So we don't really care about that right now. Okay, so we come down here, and here's where we're starting to build our UI. We have a frame, we put inside of it a panel, and then we say, let's set a widget to that panel, to that frame, which is this panel. So one frame has one panel, and panels, what they do is they let you group items so you can move them together around, and they also let you reset the relative system. So down here we have the label for Space Race, and we can use a font. So the font uses a name that we basically load. It's right here. It's just called A, just because I was lazy when I wrote the variable name. But it's basically a font that it's loaded using true type. Okay, so we go in. We have a panel for the menu. We have a main panel, and then we're adding the panel for the menu to the main panel. So we can have panels inside panels. And basically what you can do is you can have anything that's a widget, and this is our widget system. It's a little bit tiny. Anything that's in here, widget, you can basically put inside a panel. Okay, so here you have a button, and then you have a command that's going to make you switch from one scene to another. So this is how it works programmatically and how it looks. Let's go back to the demo and keep walking through it and just see what the elements look like. So I hit start. We come here. This is like an enter player scene. We have a text box. So we have a button, a label, and a text box, and they're inside a panel. There's also, this is a frame that contains at least 2 panels. Actually 3. There's an invisible one here for the rotate button. So I go here, I say my name's Alfredo. I write it, vessel name, the destroyer of worlds. Over here you basically have 2 images that just show you what weapons you have. That's another capability that we have, loading images. I just want to clarify, this system was made on top of basically Azure, but Azure had no way of handling text, so we did all the text handling, and that's a specific part of PaletaUi. And the image loading that we're doing, it's kind of integrated with Azure, and we're just using their image loading system for textures to basically load our images. So here we have a button that has a command that interacts with the scene. You can see how I click rotate and it moves the chip. Here we have more images showing us the stats, and then we have a bunch of labels put in there. And we have a button play that just basically does the same. The difference is this play button is going to switch the scene, but additionally, it's going to take the data that's here, and it's going to pass it to the next scene. So let's hit play. Here we go. So now here, this is the first scene that is declarative. And the difference in declarative is that we're writing it in XML. So you can see that my name came in, Alfredo, Destroyer Worlds, and we're using a font that's a different size for this. It's the space font, but it's a different size. And we can go back to the start screen, pressing that button, and we have our lives. Nothing's happening in the scene because I didn't program anything to happen, but in general, you could make whatever you want with the game scene and then just float your view here. You can also keep one game scene alive and change your views. There's no reason why like you can have an end-to-end relationship between a scene and views. Okay, so let's look at how this gets constructed because it's different. So to start, let's just look at the code in C#. And we go again to the initialize method of the scene. We can see here that the way you load it is you say view, current view, and you say load scene. Everything that you see afterwards is what we're doing to add programmability. So we're getting elements by name, using the get frame by name and get widget by name. And then we're basically modifying them so that you can actually get data in programmatically. But the view is where the positions is defined. The position and all the attributes is defined in the scene XML. And we're going to take a look at that so we can see how it looks. So here we go. You have a view with a name, a frame with a name, panel with a name. You have all the elements inside here that are defined. You have button, label, image, more labels. But the thing is that you can define this using the coordinate system based from 0 to whatever the size of your window is. And you could split, it's split into two. So a UI designer could work here while the guys are working on basically building a programmability function on it. I think it's a really cool way of adding content. And in order to do this, we have to build a serializing pipeline that we're going to show in a minute. Okay, so going back to this. So we're back in the demo. We're here in the start screen, and we're going to go look at the high score window. So high score window, basically what it does, it just shows the high scores. It's not particularly fancy looking, but the interesting thing about this is that that it was built in a way that we can use custom components. So if you see here, we have button and then we have high score board. So you can add to our serializing pipeline, you can add custom components. And the way we do that is by creating, first you create a widget, like high score board that inherits from widget, and you like make it the way you want. And that's what we're doing here. So I'm going to show that really quickly. So we came here, we basically inherited Proliga from widget and just implemented this draw on update. The only things we need to implement. Everything else, it's basically what the special properties that we need to set for here. So after that, what we need to do to be able to use it from the XML, it's write a serializer. And this is what a component serializer looks like. Basically, he's expecting the element. We use TinyXML as our library for serialization. It's pretty awesome, it's pretty fast, and it's extremely small. It's basically 2 files you throw in and they just work. So we pass in the element, so he's not has to do all the other parsing to get to him, just the specific element. So once we go into load, in here this is what it looks like. You basically just take the attributes and you call the setters that you need, and that's it. Your element is loaded. This gives you the ability to do calculations or anything if you need to in the specific serializer, or whatever validations you need. Okay, so to add it to the pipeline, the way our serialization works, I'm going to show it here. Focus, that's main interface. So this is widget serializer. So widget serializer, it's basically in charge of serializing the widgets, and it has a class that has a vector that lets you hold the serializer components. Inside of it, you can basically do load, and he will figure out, he uses a chain of command to figure out which widget should be serializing at this point. So it comes preloaded with all the basic stuff that comes with PaletaUi, button, text, label, panel. All of that crap is in there preloaded. But if you use the add method, you can basically add a new widget serializer like the one we were looking at, and then he will use it the same way, and it just looks native to you, and you don't really have to do anything else. Basically, this is what it looks like. So you would have widget serializer component in here, high score board would be here, just inheriting from it. So two classes let you have functionality that looks native to the engine, and that's what we did for high score board. Like if you look here, high score board, and then we have the specific things that are for him: player 1 score, player 2, player 3, and so on. Additionally, so this implements has name. It's required for all the widgets. So you can basically go and retrieve your high score board to interact programmatically with it and set whatever data you need. So let me see. What else is interesting that it's worth noting, showing here? So in order to use PaletaUi, you need to embed it in 4 places. And we have this class called UI Manager, which is a facade that lets us basically abstract the system from the game engine. So all you need to do is when you start your game, call initialize and pass the size of your window. Then set up methods so you can handle keystrokes. They're based on glut, so whatever the glut keystrokes are, it's what's expecting. And then you can fill this virtual mouse on your positioning event and on your press event or your key press event for mouse. And if you do that, then the mouse will just work automatically. That will give you clicks, make the text box set focus. Talking about that, so our text box has set focus and they work the way you expect them. You click on one and you can write on one. The way we do that is we have this handle keystroke method that calls the focus manager and basically uses it to any widget. It tells it to handle the keystroke. So whatever widget is in focus on the focus manager, we'll take the keystroke that comes in and handle it. So it's a one-to-one relationship, and the moment you change focus from one to another, it will disappear. So additionally to that, the only thing that we haven't looked at is the command system. And I'm going to go through it really quickly because it's not particularly fancy. So the command system, what it lets us is use a command pattern, but it lets us encapsulate an event that happens. It's a general one. It requires an event details, so you can pass extra data and a parent. Right now, we have 2 commands. So the commands that we built for the game, the switch scenes, they're specific for the implementation of the game. Basically, they call Azul and tell it switch scene. But we have 2 commands that come with the engine: debug command and click command. So click command is what you use for all the buttons, and debug command is basically just one that you use when we're debugging. If you want to see if an event is shooting, you set that up, and then you can watch it. All right. So basically, this is a wrap up. I'm going to load the game again, just so we can take one final look, and we can see that you can circle through it. So yeah, this works as you expected. It works with backspace, with shift. You know, you play. You're here in the game. You see a score moving, or not, we'll notice that earlier. So high scores and whatever. So we have this framework now. If we wanted to build a full game behind it, it would be pretty easy to go ahead and do it. I have a list of next steps. Hopefully we can move on in the next few weeks and do some of them. Thank you for watching and have a great day.